Sorry guys, I got so excited about doing this problem. Okay, so here's a problem that we're working on right now. Let me start over. Maybe the people here in the classroom weren't paying attention either. I don't know, we'll see. Could I write everything in sine or cosine form? Yes, I could. Right? Should I? I don't know about that. Okay? Anytime things are squared right off the bat, I'm not going to say it's never a good idea to write things in terms of sine or cosine, but when things are squared, we want to direct our attention somewhere else. Oops. We want to direct our attention here, right? At these squared terms. But let's keep going and see what other tools are available to us. Could I factor this problem? What do we look for? Right? We look for that plus or minus. If there's a plus or minus in the problem, that's the spark that says, hey, pay attention for a second. We might be able to factor this. Then look at it and say, okay, well, what's being separated by the plus sign? This and that. Do they have anything in common? Does this and that have anything in common? Common pieces, right? And don't look at the x. Don't look at the little 2. We've said this before. We have to see these trig packages as single entities. So we look at that. Do they have something in common? They certainly do. So could we factor out common terms? Oh yeah. Oh yeah, we could. Okay? What about common denominator? No, we don't have any fractions. Factoring by grouping, you need 4 terms. Binomial in a fraction, no fractions. Decompose fractions, no fractions. So factoring out, manipulating squared terms, of the 3 that could be used, let's do this one, because we haven't done that one too much. We've done this quite a bit, okay? And we can talk about 2 ways to do it, but let's factor out this common term, this secant squared x. Let's pull that all the way out to the front and look at what that leaves us with. That leaves us with a tangent squared x here, plus, when I factor secant squared out, I have to have something in its place, right? It doesn't just disappear. Factoring is division, so I'm dividing this by secant squared x. Secant squared x divided by secant squared x is 1. Now we look at that. Okay? And again, we should look at this and say, okay, the radar starts to go off. Tangent squared plus 1. I know what tangent squared plus 1 is. Okay, we're supposed to simplify this, right? But if you look at this and you say, what can I do now? Oh yeah, I can distribute the secant squared into this quantity. That would be a terrible idea because we just factored it out. So it's like, I'm going to take it out. Then I'm going to put it back in. Like 2 steps forward, 2 steps back. You didn't accomplish anything, right? But from here, if I look at my toolbox, I say, okay, what now? Well, I still got these squared terms. I still don't have any fractions, and I did all of the simplifying. So since I just did this, and I don't have 2 fractions, and I can't factor by grouping, and there's no fraction here, and there's no fraction here, I'm left with these 2 options. Now, the Pythagorean identities that we're familiar with, we just had this one in the previous example, right? This is what I mean when the radar starts to go off. The nice thing about this problem is we don't have to manipulate anything. We can make this problem simpler because tangent squared x plus 1 is sitting right in the middle of it. And what is tangent squared x plus 1 equal to? Secant squared x. And that's simpler. So there was no manipulation, it was just a substitution. It actually makes it a little bit more complicated even though it's easier. Because you can just see that it's there if you have enough experience with this and you've used that page with those identities on it. Now we can multiply these together. That'd be simpler, wouldn't it? If I had secant squared and I multiplied them, I wouldn't have a 2. We put a 2 in front when we add, right? When we combine with addition or subtraction. When we multiply common terms, we use exponents. There you go. Okay? Let's reset this and look at this alternative method real quick, just for fun.